Hi everyone, welcome back to Harshi Learn. In today's video, we are going to understand garbage collection in .NET. Okay, in the previous video, we saw that in .NET the CLR takes care of memory for us, right? But if we think about it, when our program runs, it keeps creating objects again and again. Some of them are used, but after some time, many of them are no longer needed. Now the question is, what happens to that all unused memory? Because if it is not cleaned up properly, it can affect performance and even causes issues. Correct. And this is exactly where this garbage collection comes in. It works in the background and automatically cleans up memory for us. So in this video, let's understand how GC works, what actually happens behind the scenes, and why it is so important in .NET. Okay. Before we get into how garbage collection works, let's understand why even we need it. Okay. When a program runs, it keeps creating objects in memory again and again. Some of these objects are actively used, but after some time, many of them are no longer needed. Now, here is the problem. If you don't remove those unused objects, they just stay in the memory and keep occupying space. And slowly, this can affect how application performs. Now, imagine handling all of this manually. You would have to track every object and decide when to remove it. That's not only difficult, but it's a very easy to make mistakes. And those mistakes can lead to memory leaks, slow performance, and application crashes. So instead of putting this burden on developers, .NET uses garbage collection to handle it automatically. It takes care of cleaning up unused objects, so we don't have to worry about memory management. So what exactly is garbage collection? Think it of like this. When your application is running, it keeps creating objects in memory, right? But after some time, many of those objects are no longer needed. So instead of us going and cleaning them up manually, the CLR does the job for us. Okay, garbage collection is basically a feature of the CLR that automatically removes unused objects from memory. That means we don't have to write any code to free memory. Okay, it all happens in the background. Now, this mainly happens in something called a managed heap, which is where all our objects are stored. So, in simple terms, garbage collection looks at the objects in memory and it finds the ones that are not being used and it will remove them and frees up that space. Okay. Now, let's see how garbage collection actually works. When your application is running, it keeps creating objects and all these objects are stored in the managed heap. Okay. After some times, GC steps in and checks the memory. It looks all the objects and try to understand which one are still being used and which one are not used. Okay, this step is called the reachability check. If an object is still being used, it is kept as it is. But if an object is no longer being used anywhere in the program, it is considered as garbage. Okay, then GC removes those unused objects and frees up the memory, so that space can be used again by the application. And the best part is all this happens automatically in the background. That means without us writing any extra code. Okay. So overall, first objects are created, then GC checks the ones which are used and it removes the unused ones and frees up the memory. Okay. Now, here is something very interesting. .NET doesn't treat all the objects the same. Instead, it creates memory in different generations to make garbage collection faster and more efficient. When objects are created, they first go into generation 0. Now, most objects in an application are short lived, so this area is checked and cleaned very frequently. Okay, and this helps us to remove unnecessary objects quickly. If an object survives in Gen 0, it gets moved into Generation 1. You can think of this as a middle stage. Okay, it contains the objects that live longer than expected and may not be needed forever. Okay. And if object continue to survive, then move to generation 2. Okay. These are long-lived objects. Since they are usually still in use, this area is cleaned very less frequently. Okay. So in simple terms, object starts in Gen 0. If they survive, they move to generation 1 and then move to generation 2. And also remember, short-lived objects are removed quickly and long-lived objects stay longer. Okay. And this approach helps to improve performance because GC focuses more on cleaning objects that are likely to be unused. Now, one important thing to understand here is garbage collection works only with managed memory. That means it cleans only the objects created by .NET. But there are some things that GC does not clean, like database connections, network resources, unmanaged objects, and file handles. Okay, these are not handled automatically. So we have to clean them ourselves. Okay, for that we have dispose method and using statement. So let's quickly recap what we have understood. Garbage collection runs automatically in the background, so we don't have to worry about managing memory manually. And it keeps checking for objects that are no longer needed and it removes them to free up space. Okay. And at the same time, it works only with managed memory. So anything outside that still need to be handled by us. Okay. And overall, this whole process helps the application run smoothly and it will improve performance. So this is how garbage collection works in .NET. It automatically takes care of cleaning up unused objects so we don't have to manage memory manually. And because of this, development becomes much easier and we can focus more on writing our application logic instead of worrying about memory issues. And at the same time, it helps the application run more efficiently. Okay, and that's all for this video. I hope this made the concept of garbage collection clear and easy to understand. And if you found this helpful, don't forget to like and subscribe to Hershey Learn. And I'll see you in the next one. Until then, keep learning and have a great day.